Hello everyone. In this video, we are going to solve question number 86 of set B. So let's try to solve it. So before answering it, we know that if we talk about the combustion of any hydrocarbon, it can be represented as CX HY plus X plus Y by 4. This is very important, you should know this. O2. Right? This will give us what? This will actually give us XCO2 plus Y by 2 H2O. Correct? So this is a general reaction which follows. Now let's just try to replace this. We have benzene over here. So let's try to replace it. We have C6H6 plus X, right? It is 6 over here. So we'll get 6 plus Y is also 6, 6 by 4 O2, and from here what do we get? If you try to replace it, X is here 6, right? 6 CO2 plus Y is again 6, so we'll get 6 by 2 H2O. Now if you solve the equation, it somewhat comes out to be, so here we'll have 2, 3, so the equation comes out to be C6H6 plus what comes out to be here? It's 15, right? 6 to 12, 15 by 2 O2, and next we have 6 CO2 plus here we have 3 H2O. So this is the equation which we will get. Now from here, now if you try to represent the equation, right, of combustion, we state it as delta H is equals to delta U plus delta N RT. Now if you try to just evaluate the numbers, evaluate the forms, that is delta H, this is heat of combustion under constant pressure, which has actually been asked to you, correct? This is heat of combustion under constant volume, which has been given. Delta N, it is basically the difference in the moles of the gases, and R universal gas constant, this is temperature, which is given as 25 degrees centigrade. So we'll represent this in Kelvin. Now if we just replace the numbers, what we get? Delta H is equals to, delta U is given as minus 3263.9, okay. Delta N will be, delta N, what do we have? So here we have 6, correct? So let's try to represent this. So here this is liquid, this is gaseous, again this is gaseous, and this is liquid, correct? So what we'll get? 6 minus 15 by 2, so here we get it as 6 minus 15 by 2, and now 8.314 and 298 kelvins, correct? Now here in this equation, we have to divide this by 1000. Why? Because it has been represented in kilojoules, correct? So now if we actually calculate this one, the answer which we get is delta H will be minus, it is minus 3267.6 kilojoules. So this is the option which has been given, and this will be the answer, correct? So here basically you should know this basic representation of the combustion of any hydrocarbon, and also how to represent this. During the calculation process, of course, we have to know which is in the liquid and the gaseous form, because from there we will just calculate this delta N, correct? So here from here we have calculated delta N, this comes out to be minus 3 by 2, and if we calculate this, and also importantly we have to divide it by 1000 because it is represented in kilojoules per mole. So the answer is minus 3267.6 kilojoules.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.